manufacturing, technology, hot topics, and a little bit of tomfoolery. This is the MTD Podcast.
Welcome back to this week's MTD Podcast, episode 11. Episode 11.
How do you know it's 11?
Because there's two ones.
The last one was 10.
Oh, there you go.
Just
ask a simple question, don't
When we go up, we don't go down.
And all four of us back in the studio.
Yeah.
Paul,
Yeah.
Gio, Colin, and Mr. Foolery.
Yeah, Tom is back. Right, and we're going to be talking about today work holding in a minute. Work holding on turning machines, milling machines, how Industry 4 is affecting work holding, automation in work holding. So lots to get our teeth stuck into.
Episode 10, work holding for EDM machines?
Possibly, yeah, that can come into it.
Tossing it in there?
Yeah, you need work holding to hold things, and that's really what it's about.
In the name.
But before that, how are you, Gio? You all right? You back up to full speed
Still
now?
got the lurgy.
Getting there, Paul, getting there. So, yeah, bit by bit.
Good. Colin, you all right?
Yeah.
Good. Yeah. So.
Oh, did you want more than that? That's what I got, mate. No more dates since last. Well, no more dates cancelled, blocked, ignored, whatever since last time. So
You've been on a date since last time.
Gee, I didn't know you cared.
So that means no then. Any other gossip? Anything else happening? Where you been? Anyway, good?
EDM event was brilliant last week, wasn't it?
From Fanux.
Absolutely fantastic.
But on from our EDM podcast, I thought that was superb. It was a good mix.
That's tied in nicely, didn't it? I was lucky at that.
Yeah. Now, we've got a work holding specialist here. In fact, you're doubling up today.
Is that Tom Foolery?
You used to sell work. In fact, so did I. I used to sell work holding as well. In fact, I competed against you.
What work holding did you sell, Paul?
I sold microlock clamping system.
Bloody hell.
many moons ago.
Oh, and then Jesse got decent salesman.
He did, yeah. There's a funny story actually, which we can come back to later about my sales of microlock work holding.
Is it a long story?
No, it's quite a short one.
Okay.
Do you want me to tell you it now?
Yeah, go on.
Yeah, okay. So the microlock work holding system, it's got a base plate, a grid plate, and then you've got clamps and locators on it. I used to knock on doors all the time, trying, are you interested in these base plates and vices and all the rest of it? Yeah. And one day I went to this company called Gemini Gears in Brackley. I don't know whether you ever heard of it, Gia, did you? And they just bought a load of Hitachi Seiki. Yeah, very good. They just bought a load of Hitachi Seiki vertical machining centres. And these machines...
Can you call them Hitachi Seiki?
Yeah, that was what they were then. And they just hit the deck. Brand new machines, right? And this guy, opportune, I turned up with a catalogue and he looked and he saw that it was a work holding solution. And I said, look, these are perfect for your new machines. Cover all the tables on these Hitachi machines. Bearing in mind, there must have been, 8 to 10 machines. And he was like...
Cha-ching.
And I'll never forget the guy's name. He was called Warren. Warren Gears, he was called, but and anyway, in the end he rang me up and he says, "Yeah, I'll cover all my tables. I want to cover all these 6 or 8 machines." So I was like, "Great!" So he placed the order. So we made all these base plates.
Oh dear,
what's coming?
I just anticipated it's going to be bad, isn't it?
So we made all these base plates, delivered them to site, and then of course, as a salesman, what you always worry about when you're selling is when an installation goes in, you just don't want the phone to ring, because if that phone rings, they never ring you up and say, "Thanks a lot for that installation. That's gone really well."
Do they not, Paul?
No, there's always, you missed this off, you missed that off. Anyway, so I picked the phone up. Hi Paul, it's Warren here. Yeah, how you doing? Is everything? Yeah, it's all turned up, but none of the vices or the clamps are turned up. And I said, "But you didn't order any. You just ordered the base plates."
Oh, no, Paul.
So you can imagine that was a pretty frosty conversation, because I naturally thought he was going to use his own clamps on the microlock base plate.
Because they're universal.
Correct.
I think you missed out on a sale there, Paul.
Well, possibly. But he did have to buy some, because
no, that's not a sales technique. Sell them half a product.
Did he buy a game, Paul?
No, because I think something happened to the car. I don't think the company is anymore. But yeah, basically, I remember thinking, my heart sunk. I thought, oh my god,
no.
We're going to have to give him a load of clamps and vices. But he bought some and we gave him some, and it all worked out well in the end. So that's my story.
Just don't tell Matt Jeunesse.
No.
Anyway, you said it's a short story. Moving on, work holding.
Yeah.
Talk to me.
Well, if we're talking about milling, which is a good place to start, there are so many options, aren't there? Yeah, Gio, you've been selling work holding for many years as well. Did you ever make similar mistakes to what I did?
I think, we all miss something out now and again. Yeah, definitely. I think it's one of them things, you try your best and that's all you can do. But for milling machines, there's so many different options available. I think that what I'd like to touch upon today is kind of, what new technology is out there in regards to work holding. I mean, you see a lot of old 1960 style work holding solutions on brand new state-of-the-art machines now.
But doesn't that say to you can't move technology forward? It's going to be work holding?
No, I don't agree there. No,
that's a question. I wasn't.
Yeah, no.
Let's have a dust up in the studio.
I think, in my opinion, that from my experience on the road, I think work holding is really overlooked massively. So they'll have a budget for a machine tool, and they'll overlook the tooling and the work holding, and they won't invest in it accordingly. But ultimately, what that does is they're not protecting their investment. So when you haven't got the correct work holding, you're getting vibration into the machine tool. You're not being able to use the correct speeds and feeds. So you might as well have gone and bought a second-hand machine tool. And instead of investing in the machine tool that you wanted to save seconds and minutes on your components.
But that's a story here everywhere, isn't it? Oh, I've got a fantastic new machine. It's cost me, I don't know, say 100 grand. But they haven't bought the tooling, the work holding.
Why haven't they?
Well, you must have been in that situation where you must have gone into countless companies and seen new machines and gone, why are you still using that old vice?
Yeah, absolutely.
And, is it a fault of the salesman of the machine tool to not say, Dave, for argument's sake,
you're a machine tool salesman.
You're buying this £100,000 machine. Have you not considered adding another £2,000 on top of that and sorting yourself out with a decent work holding solution?
Paul, did you do that when you were a machine tool salesman?
Yeah, but I used to sell them without the clamps. But is that not the case where maybe it's a bit like bar feeds, it's a bit like all of those other accessories? Is it whose fault? Where does the blame lie?
I don't think there's any fault necessarily. I think it's a case of habit. People have always done it in a certain way and think that works, and they don't realise a better way of doing it until someone can come in and illustrate to them that, look, with all due respect, it's worked for you before, but you need to move on now.
So that's like Colin when he chats up women. His habits don't change. He always does the same, and we've told him on countless occasions that much of the same will get much of the same result.
Yeah, but on a positive note. No, actually, let's get back to work holding, shall we? So,
I've never seen you stick for words.
Gio, don't you worry, it works. I just wouldn't want to share it with the world, because otherwise, women moving on to work holding on a mill.
So there's lots of different options available, and again, coming back to, I believe personally that you can get your best return of investment from work holding more than your machine tool. Your machine tool should be purchased according to the components that you're going to make, but then you want to utilize the envelope of that machine tool and be able to present as many components as possible to that spindle, and also be able to machine them components as quickly as you possibly can. Without having the correct work holding, you can't achieve that. So from a small investment, you can get your best return of investment. And this is something that people need to be made aware of, really.
So basically, when you're buying that machine, you need to speak to somebody about the work holding solution. So, for example, the amount of component left when you're pre-stamping, for example.
That's if you're doing fifth axis machining, really, if you were looking to just hold on minimal excess material. But it depend on any application that you're looking to do, whether you're looking to hold the component in a chuck, in a vice, in a fourth axis rotary table, whatever the case may be. The work holding is key to the process that you look and the components that you're looking to machine. From the accessibility of the spindle to the component, from eliminating vibration, which is a killer of the spindle, and tooling and cutting tools.
We take advantage of the knowledge that we have around this table, based on our activities out in the field. Okay, and I see some
not Boris Johnson sort of activity in the field. No.
Wry smiles here. But I'd give you an example, and this probably answers or concurs with what Gio's saying. I remember when I was selling work holding and going into a company, and he had one vice with one billet on the table, and he was buying another machining centre, right, to put another vice and another billet on that machine, right? He hadn't considered. Now, I get the argument that there's 2 spindles now as opposed to 1. I get that. But he hadn't considered that by using the system that I was offering him, he could get multiple components in, on a table, 8, 10, 12. And therefore, I get the fact, like I say, there's another spindle, but how much more efficient would that make him? Because he's finishing a part every time by having 2 or 3 or even 4 or 5 face ops throughout the base plate. Now, that's an example of someone that is just historically used a vice on a machine and they just think you can get 1 part on it.
Absolutely. There's a company in Wales, I won't mention any names, I went into this
we'll
account
turn the recorder off for a minute.
3 or 4 years ago, maybe a bit more. And basically they had a cell of machines doing parts for the aerospace industry, 6-sided work, so 6 operations, and basically they were twin pallet verticals. So they'd have a vice on each pallet. So I think they had about 6 machines, so you've got 12 pallets effectively altogether. But they were only doing 1 operation per pallet. And once we palletized each pallet, so we managed to get 3 0-point systems per pallet with 12 components on each pallet. So you've got 36 components per pallet doing op 1, op 2. So you can just imagine the productivity gains that they got overnight. It wasn't a cheap investment because there was quite a bit of work that went into it. However, the productivity just went through the roof. It went absolutely through the roof, and that's a perfect example.
What's 0 point, Colin?
No idea, mate.
And it doesn't mean there's no point to it.
Absolutely. No, returning it every time to the same place. Absolutely.
Yeah. So, but that just, you're probably best placed again, Gio, to explain that.
Well, he's in a 0 point.
Is that exactly it? Is it a case of setting taking, let's say, a collet out of a chuck and making sure it returns to exactly the same place every time?
There's other benefits to it as well. So say, for example, before, and using this customer as an example again, they were putting the components into a vice. So there's loading times. You've got to make sure that the component's up to a stop. It could be loaded incorrectly, for example. But when you're palletizing it and you've got it on a 0-point system, especially when you've got 12 components on the pallet, you can do the loading of the components off the machine. So when the machine stops and you transfer over your pallet, the pallet is loaded absolutely spot on, it's correct, and it repeat in exactly the same position. So you're making the process foolproof as well. So you're trying to eliminate operator error as well.
Yeah.
So.
Well, actually, talking about that, and you're saying about repeatability, I was just thinking Mayland Pallet Master, because there, machine's running, you've got all the components being milled in, as an example, take it out, load the other one up, keep it going, running.
And that's taking it to the next level, is really.
So 0 point is becoming popular. Blue photon, Colin, what's that?
Don't know. No, of course I know. It is essentially tricky parts. You're holding them, so you're not, with a clamp, for example, you might get distortion if it's, three jaws on it. This, you're holding it with a piece of resin. Well, a piece of resin, you're gluing it on basically, so it's really tricky parts. Great example is aerospace, airfoils, as an example. And then
How does it secure it?
So you're basically gluing it onto the work holding.
Is that a solid mount?
So yeah, it is. So I say you have to cure it. Ultraviolet light cures it, and that is holding it.
And how do you release it?
It is with a steam cleaner. It's as simple as that. Like your Karcher.
Well,
systems.
it breaks off. It breaks.
Sorry, snap it off.
It snaps off, and then it gets cleaned, and then you start again.
Right. So, because the best analogy I heard was about like a spider. Imagine if you had like a spider with six legs.
Six-legged spider. Can we just clarify? Paul lives in Rushton, where they only have 6-legged spiders.
And you wanted to machine the body on the top. That's what and you would essentially, that's sort of application.
Can I just clarify, Paul? That analogy. That you how long ago did you hear that? I think about 5 minutes, because we were just discussing it with Gio before we started. Gio, don't let him try and get away with it.
I've given away the secrets.
I think there's so many different work holding options out there, and I think it's all application specific. Really,
magnetic.
Yeah, magnetic again.
My personality straight away. What do you want to know?
So you've got
south.
Permanent magnetic work holding solutions, and again, for the right application, I think that if you're doing,
are you limited on the size of the actual base plate with electromagnetics?
No, I mean really, the larger the component, the better. So because the more surface area you're covering, the more clamping force that you get. On 3-axis machines, 5th-axis machines, horizontal machines, if you've got big billet work, magnetics is brilliant solution for
what about, I saw one, ceramics and things like that, ice vice, because you can't, there's an issue with coolants and things like that. Ice vice, you can
Yeah, you need a cooling off period before you go.
It's a bit frosty.
Oh my God,
Yeah,
please. But you can do really tiny, intricate parts, such as ceramics on this. It'll hold it with, essentially, well, it is a very complex chemical compound, H2O.
Is it a bit
which
like,
is water to you, Paul.
Is that a bit like ice? So when your fingers get stuck to ice,
It's the
same sort of thing.
Yep.
Oh, okay. So it's a little bit similar to the magnets in a sense that with magnetic work holding, you're looking to machine all the way around. So there's no overhanging clamps and, and vices, and the ice vices are similar. Who does the ice vice?
Leader Chuck. I can't remember who the actual manufacturer is, but Leader Chuck.
But also not to distort parts as well, isn't it? So if you've got really thin wall parts where you just can't, really thin wall parts, the ice chucks, it's a good solution.
What about turning then? What about turning on turning centres and lathes? We're talking chucks, collet chucks, mandrels or mandarels or
easy use ones. We saw a great example at Southern the other week. Even our cameraman could work it. That was a Heimbuch one, wasn't it?
Yeah, that was Heimbuch. Yeah. The Heimbuch solution.
Other solutions are available.
But the Heimbuch system is a quick change system, which means whether you go from a collet chuck to a mandrel. Is it mandrel or mandrel? How do you pronounce
Expanding
it?
Mandrel, really, I'd say they're more for the second spindle. So when you're transferring work from the main spindle to the second spindle, if you've put the bore in on the main spindle as the operation, then it can be transferred to the second spindle, held internally, and then machined externally on the second spindle and then finished.
But have you seen how fast the Heimbuch system is to change from a collet chuck to a 3-jaw to a mandrel? You can do it literally in seconds, can't you?
They've really simplified it, and it works. I think that you can incorporate it with lots of different applications. It's very modular, and even I've seen a video where they've automated it, but not only automated the actual process, but automated the setups. So the robot can actually change the collets because of the 3 pinpoints in the collet. The robot can come in and change the collet. So usually when you're looking at automating a lathe, you assume it's just, running the lathe with a robot and taking the parts in and out, and that's it. But they can actually, when you're going from setup to setup with Heimbuch, it's quite clever because you can actually change the setup. So if you're looking to change the part, you haven't even got to involve the operator for that either.
Okay, so you're able to machine different components, and the robot arm will change that.
It will change all the collets. Also, they have, in line with Industry 4, one of the things I saw at an exhibition a couple of months ago was they had a system where they had it was measuring the clamping force. Once you put the robot had loaded the collet, the bar was in the collet, it was tightened up, and if it went green, it meant it was at the right clamping force, and if it went red, it meant there was either an issue with the bar or it wasn't clamped. So they knew then that.
Not that there's just too much clamping force. There was something an issue with the bar.
It could be either or, because generally, if there's a contaminant or something on the bar, it would affect the clamping force anyway. And that's their sort of entry into Industry 4.
Do you think then Industry 4.0? This is, Gio was very passionate about this because someone said to him the other day, for work holding, you don't need Industry 4.0. Shh, don't tell anybody. But Gio,
well, I think that you couldn't be further from the truth, really, because I think that
dust up in a car park later.
Because Industry 4.0, in my opinion, would be flawed if the work holding didn't work accordingly. If you were still using traditional 1960 technology, mechanical technology, how can you gather data from that technology? And if if the work holding was causing the vibration, and your machine is all Industry 4.0 ready, the tooling was all Industry 4.0 ready, you can't just assume that the work holding is perfect and working correctly and get that data. You'd probably put the vibration down to the spindle or the tooling, wouldn't you? So all of your results would be
so you're only as good as your weakest link. It's
Absolutely.
A bit like our football team. The goalkeeper,
the manager.
it doesn't matter
I
what
think it was
the
the manager
pitch.
was the weakest link.
If the goalkeeper keeps leaking goals, then you're going to lose the game.
Can we just clarify? Can I just clarify? Who got man of the match in the last match?
Don't know. Wasn't it the manager?
He's got two hands up at the moment.
Who got manager?
And it's not
of the,
because he's been
who got
robbed.
Manager of the month last month?
Not you. No,
Who got the sack?
Mick Harford from Luton got manager of the month. But we move on quickly.
Well, we were talking to Fanuc last week at the EDM event, and they're on about taking on MTDCNC and using a robot in goal.
Yeah. Well,
probably be better.
Yeah, it would be. Yeah, we give it the eyes, wouldn't we? Give it one way and then the other. So on the turning side, but you've also got things like the mandrels. Mandrels. When you start getting into things like steadies, that's not really work holding, or is it?
It is. Yeah, it's all part of the process.
Quills.
Isn't it? And I think that
if you're writing an essay,
you've got drivers as well. So you kind of part drivers, so you can drive the parts and turn the old, to keep concentricity. So if you're doing long shaft works with different diameters.
And what about things like the Interflex chuck from Tame? Have you seen that? Where it doesn't matter, you've got 4 jaws, but they sort of all independently work, but they will centralise the part. Do you know what I mean by that? Is that a good way of describing it?
Yeah, I think if you're doing prismatic parts or irregular shaped parts, I think it's a great solution to be able to put it onto a lathe. So say, for example, if you were looking to hold a prismatic part that had a shaft on it and you wanted to load that prismatic part into the chuck and then turn the shaft, it's perfect.
So just clarify, an irregular shape, but it's the jaws will centralise it.
It centralises it automatically as and I can't remember the mechanics behind how it actually works, but it's been a very popular product for them, and it's solved a lot of issues for manufacturers. So that is obviously a solution that's available from Tame Work Holding. When it comes to beyond milling and turning, though, grinding, I mean, it goes on, doesn't it?
EDM.
Work holding. EDM.
Yep.
Yeah, it really does. I mean, there's so many different products out there that we could spend a lot of time talking about. But hopefully that's given you a good insight into some of our knowledge anyway. And that's it for today's podcast. Thanks for joining me.
Cheers, Paul.
Gentlemen.